Sketching functions is one of my favorite topics. Going from an algebraic expression to a picture is pretty neat, and applying, the concepts and ideas that you know about the functions. Now, let's have a look. So I'm going to look at the first one. Y is equal to x plus 1 times 2 minus x. This is a quadratic because when I multiply the x and the minus x, I'll get minus x squared. That will be my leading term. And furthermore, it's a sad quadratic or negative quadratic. It's going to look like this. If I was to set y equal to 0 to find the x-intercepts, then I'll get minus 1 and 2 as the x-intercepts, and the y-intercept will be just a constant 1 times 2, which is 2. Like if I expanded it out, I would get minus x squared plus 2x minus x, so plus x plus 2. And that 2, when x is 0, that's what you have for the y-intercept, you'll get that y is equal to 2. So that is enough information to plot this, and I'm going to do that before I plot the other one. Sometimes it's good to, sorry, not plot the other one, look into the other one. Sometimes it is good to look at the other one first because it might affect the scale, but sometimes it's just good to get like start the picture off. Right, we've got a root at minus 1, and then this one will be about here at 2. So it's not perfectly to scale, but I'm just going to put it roughly in the right place because then it will look more accurate. And it's a sad quadratic, so it's going to come up and then back down. Note the maximum is going to be after the y-axis because it's going to actually be equidistance between minus 1 and 2. And here's my 2 there. Let's take a look at the second function. We've got a modulus sign in there. Don't forget the modulus function. If x is positive, then it doesn't do anything at all. And if x is negative, then it gets rid of the negative. So if it was a minus 1, the modulus, it just becomes 1. And what we get essentially is it's going to become minus whatever x is. So minus minus 1 is just 1. This will necessarily make it positive. And therefore, if we have y is equal to x squared minus 2 modulus of x, then like I said, if x is positive, nothing happens. If x is negative, then we're going to replace this by negative x, so it will actually become plus 2x. And again, this is a quadratic. I'm going to factorize it by taking the x out. And I'm going to clearly get a root of 0. Let me do this in purple, in fact, which I can put here. When x is greater than or equal to 0, I'm going to get this root of 2, so it will go through here. And then I'm going to get a root of minus 2 here. So I can now just focus. It's also, both are going to be happy quadratics, like the right-hand side and the left-hand side, with a y-intercept of 0. And therefore, if I just look at the positive side, well, this is the root and this is the root, so it's going to come down and then back up. And then over here, it's going to be exactly the same. Down and back up. We're just treating the two sides a little bit differently. But that is going to be our answer. Now, what does it say? It does say the coordinates of the points. I kind of felt like I've done enough, but I should probably, if I'm just being super careful, it's going to write down the full coordinate 2, 0. This is going to be 0, 0, 0, 2. Maybe I should even cross off those. Just felt quite natural. I should get away with it, Actually, I think it's a little bit clearer, in fact. But now I've written the coordinates in full. That was part A. Let's take a look at part B now. Find the x-coordinates of the points of intersection of these two curves. So we're going to have, we can see, got one here, and we've got 1 here. Because we've drawn our sketch accurately, in fact, we already have one then, we can say that x equals 2 is a solution by looking at this right-hand one. The other is when I can take this red function, x plus 1, 2 minus x, and it's this blue curve. It's when it's equal to the negative, when x is less than 0, part of the other curve. So it's going to be this one here, x squared plus 2x. I don't need to look for the other solution. I've got it. So if I expand this out, and we did this before, it's going to be minus x squared minus x plus 2x plus x plus 2 equals x squared plus 2x. So 2x squared plus x minus 2 equals 0. And typically try and factorize this. So it would have to be 2x and x. And then we'd have to try 2 and 1. But if we put 2 and 1 here, there's no way that we're going to get x, because I'm going to get 2x here and 2x here. So that won't work. If I go with 1 and 2, I'm going to get 4x and x. There's no way I can combine that. So basically what I'm trying to say is that this is not going to factorize. And we can use, let's go with quadratic formula. Minus b plus or minus b squared minus 4ac all over 2a. 4 times 2 times 2 is 16, double negative, so we're adding 16, so it's going to be root 17. Now, this gives us 2 solutions, but it's actually given us a spurious solution, because it's given us what we would get if this curve carried on here. That would be for a positive value of x. So I'm going to reject the positive value of x. Reject minus 1 plus root 17. This must be greater than 0, since positive. Therefore, x is minus 1 minus root 17 over 4.